All right. Hello and happy Monday. Today is December 14th. This is for those students who missed today's class. You're going to be in your year view and we're going to be going to our Forces in Motion project. Your checkpoints should all be green at this point. If they're not green, you need to be using the sixth grade checkpoint directions and specifically this section right here to get caught up on your project. This has everything that we have done so far for the project. So if you have not completed a checkpoint, you have to get those checkpoints done before I will grade your final product. So we are on the Save the Egg TCT. This is our final product. We'll be chunking it and breaking it down piece by piece this week. So we're just going to do A and B today. So I want to set up the scenario first. This is a Save the Egg TCT. So it says a group of students collected the following data for an egg drop contraption they developed. So we have some friends who have an egg that they're dropping, and they have created different sized parachutes that they're attaching to the egg and using to drop the egg. So they have 3 different sized parachutes. One is a 5-inch parachute, one is a 10-inch parachute, and one is a 15-inch parachute. You'll notice that they did 5 different trials for each parachute, and then they took the average time that it took for the egg to drop. So we got a couple different things that we need to talk about with this egg drop. There's 2 different types of forces that we see in the egg drop. We see gravity, which is the downward force, causing the egg to come to the ground. And then we also have air resistance, which is the upward force on the falling egg. So when air resistance is occurring, that it is pushing up. And so it's kind of slowing down the egg because air resistance is trying to stop it from getting down to the ground. So 2 forces, gravity and air resistance, and they oppose each other, okay? So gravity is trying to get down, air resistance is trying to push that egg up. All right, so we see that we have our 5-inch parachute. Trial 1, it took 4 seconds. Trial 2, it took 6 seconds. Trial 3, it took 5 seconds. Trial 4, it took 6 seconds. And on trial 5, it took 4 seconds for the egg and the parachute to get to the ground. At the 10-inch parachute, we've got 10 seconds, 9 seconds, 11 seconds, 9 seconds, 12 seconds, which averaged a 10.2 second drop time. On the 15-inch parachute, we've got 17 seconds, 20 seconds, 18 seconds, 17 seconds, 16 seconds for an average of 17.6 seconds for the egg to drop to the ground. What do we notice about this data and the drop time compared to the parachute size? Every time the parachute size increases, the drop time increases. More space, more air resistance, slowing that egg down, okay? So letter A says, after analyzing the student's data to identify a pattern, describe the relationship between drop time and parachute. So right here, you're going to use a complete sentence and you're going to tell me, what do you notice? What is happening as the parachute size increases? What's happening to the drop time? One simple sentence. What's happening as the parachute size increases? What happens to the drop time? Complete sentence, capital letter at the beginning, period at the end. B says, using the relationship you identified, predict and estimate how the drop time would change if the parachute tested was 20 inches in diameter. So on this question, or on this, on B, you're telling me what is going to happen if they were to increase the parachute size again. What if they increase it to 20 inches? And you can even look at the data and you can say, okay, we've got an increase of 5 seconds every time, roughly an average. What would maybe be the time if it was a 20-inch parachute? Okay, that's going to be a complete sentence, capital letter at the beginning, period at the end. Don't overthink it. What is happening if they increase the parachute size to 20 inches? What happens to the drop time? That is really all you're doing today for this. You're not going to submit the final product. We will do parts C and D later in the week. So all you need to do is make sure you have A and B, and you should be good. If you have any questions, please reach out to your science teacher, and we will be happy to help you. Have a great day.